In a previous video, we discussed about a translation matrix for a two-dimensional object, and in this session we are going to discuss about the rotation of a given point in a given environment. Now, a two-dimensional rotation is applied to an object by repositioning it along a circular path in the xy plane. Now, consider a point P xy is the initial position at a distance of r from the origin. Now at an angle of phi. This is the initial position of the point Pxy. Now when we are going to rotate that point at an angle of theta at the same distance r, and that position we call it as a new position, as a rotated position. P dash is equal to x dash and y dash. Now here let us consider the rotation of the object about the origin. Here the constant distance of the point, that is a r, we consider as a r from the origin at an angle phi. It is the original angular position of the point at a horizontal, and theta is a rotation angle at a distance r, and that is a new point P dash and x dash. And we can express this transferred coordinates in the form of angles theta and phi as. Now here we have to find out the rotational position of the two-dimensional object. We also call it as a rotation matrix. How we are going to derive this? R is equal to cos theta sin theta minus sin theta cos theta. Now how we are going to obtain this equation for rotational matrix? Consider, and this is the diagram we are going to use. The same thing, phi is a initial angular position at a horizontal, r is a constant distance from the origin, and p is the initial point of a initial point of the two-dimensional object. Now we have to rotate that point at an angle theta at the same distance from the origin. And before we are going to discuss these things, now we have to first understand a simple trigonometric formulas. Okay, these are the things are very important to identify the rotation matrix. Now take an example A, B and C, and small a, small b and small c. Now we have to take this as A is the opposite side, B is the adjacent side, and C is the hypotenuse. When you are going to find this A, that means angle A, a sine and cos. Now here first we have to find out a sine A. Sine A is equal to opposite side divided by hypotenuse. Opposite side means that is A divided by C, and cos A is equal to B by C, that is adjacent divided by hypotenuse. Now consider here. Now first we have to find out the original coordinates of the point in a polar coordinates. The original coordinators we have to find out first, x and y. Now take it as a x, this is x, and this is y. We have to find out. Now x is equal to, consider this here, and this is a x, we call it as. Now x is equal to, what is this? X by r adjacent divided by hypotenuse, that is x by r. Then cos theta is cos phi is equal to, first we have to find out cos phi is equal to x divided by r, then r is equal to x cos phi, or x is equal to r cos phi, sorry. Now in a second one we have to find out the sine phi. If you want to find out the sine phi, that is opposite divided by hypotenuse, that is y by r, then y is equal to r sine phi. This is the thing we have to remember. Next, now we have to find out the angle after rotation. This is the before rotation, that is r cos phi, and y is equal to r sine phi. This is the position of the p, x and y. This is the original position of the initial point. Then we are going to find out the new angle after rotation, that it becomes p or p to p dash. Now we have to find out p to p dash, what is the angle. Now up to here we have a phi, from this we have a theta, then p dash is nothing but it is p dash is equal to phi plus theta. Now it become a phi plus theta. Now we have to find out x dash and y dash. Now we find out the p dash is equal to theta plus, sorry, phi plus theta. Now secondly we have to find out what is x dash and y dash, and these two are very very important, because when you are going to find out x dash and y dash, in this cos phi is equal to x divided by r. Now when I am going to consider this as a x and this as a y, this becomes x dash, and now this becomes y dash, and x dash is equal to, and y dash we have to find out. Then x dash is equal to, similarly, adjacent divided by hypotenuse, that is r cos phi plus theta, and y is equal to r sine phi plus theta. Here we have to find out a theta, add theta to this, we have to find x dash and y dash, whatever the angle after rotation. Now this is a simple trigonometric formula. There is a cos AB and sin AB, sin A plus B, cos A plus B. The formula for the cos and sin A plus B, what is that? Cos A plus B is equal to cos A plus cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B, and sin A plus B is equal to cos A sin B plus sin A cos B. Similarly, sin A plus B is equal to sin A cos B plus cos A sin B. Now we have to find out x dash and y dash. Now in this equation, go through this. R cos phi plus theta is equal to r cos phi cos theta minus r sin phi sin theta. As we earlier discussed, said that cos A plus B. Here r cos phi is nothing but x. This is r cos phi is equal to r cos phi is equal to x. Then it becomes x cos phi, then r sin phi is equal to y, then y sin phi. Similarly for the y dash, r cos phi is equal to x sin theta plus r sin phi is equal to y cos theta. Now the next position is x dash and y dash position. They given that x cos theta minus y sin theta, and y position is x sin theta plus y cos theta. Now the above equation can be represented in the matrix format. Then x dash y dash is equal to x and y, take it as a common. Now the matrix we have to put that cos theta sin theta and sin theta and cos theta. Now here there is a two conditions are there. That's why, that is, when the rotation taking place in the anti-clockwise direction, when the rotation taken place in the clockwise direction, when it is moving in a anti-clockwise direction, the value of theta is positive. When it is moving in a clockwise direction, then it is become a negative. Now the whatever the equation which is given for that is a clockwise direction, counterclockwise direction, because the theta is moving in a anti-clockwise direction. Now see that cos theta minus sin theta plus cos theta, that is a p dash is equal to xy, that is p into rotation matrix. Now the rotation matrix is cos theta, sin theta, and minus sin theta, cos theta. Then we have to find out the similar for clockwise direction. Okay, what will happen? Now same thing, it is important note that the positive values for the rotation angle is defined counterclockwise, and the rotation about the rotation point, and the negative values rotate object is in clockwise sense. That means r dash is equal to cos minus theta sin minus theta minus into minus sin minus theta cos minus theta, then multiply with the cos minus theta equal to cos theta, sin minus theta equal to minus sin theta minus into minus plus, that is sin theta, then cos theta. Here they given that condition cos minus theta equal to cos theta and sin minus theta equal to minus sin theta. Now only the difference is in a rotation matrix in a clockwise direction, the sin theta, cos theta, minus sin theta and cos theta. In the when it is moving in a counterclockwise or anti-clockwise direction, then cos theta, sin theta, minus sin theta and cos theta. And these are the things we have to remember when we are going to solve the problems, whether the point is rotating in a counterclockwise direction or anti-clockwise direction or in clockwise direction. Based on that, we have to use a rotation matrix. There is a one problem I taken as an example. The point 43 is rotated counterclockwise by an angle of 45 degree. Find the rotation matrix and the resultant point. Now just take it as a p is a 4 and 3, that is x is somewhere and y is here 3 and 4. Now we have to rotate it at an angle of r, at an angle of 45 degree in counterclockwise direction. That means it's similar, when the rotation is in a counterclockwise, then we have to use cos theta, sin theta, minus sin theta, cos theta. Now cos 45 minus sin 45, that is the theta is nothing but it is 45 degree, then minus sin 45 and cos 45. When we are going to find out the cos 45, it is a 1 by root 2, then 1 by root 2 minus 1 by root 2, 1 by 2 minus 1 by root 2. Now we have to find out the p dash. Then p dash is equal to p plus r, p into r. P is nothing but it is a initial position of the point, that is 4 and 3, and it is a rotation matrix 1 by root 2, 1 by root 2 minus 1 by root 2, 1 by root 2. When we are going to solve this 2 by 2 matrix into 1 into 2 matrix, then we are going to get the final values 1 row and 2 column matrix, that is 1 by root 2 and 7 by root 2. You just take it as 4 into 1, that is 4 by root 2 minus 3 by root 2, then 4 into 1 by root 2, that is 4 by root 2, then 3 into 3 by root 2 plus 3 by root 2, then 4 minus 3, that is 1 by root 2, then 4 plus 3, that is 7 by root 2. We can also solve this problem in the decimal points. And this is all about the rotation matrix when it is in counterclockwise or clockwise direction. In the same problem you have to solve or try it when it is rotated at a 45 degree in a clockwise direction. Then what happen? Cos theta minus sin theta and cos theta. Then the same values what we are going to get it. And this is all about the rotation of a two-dimensional object at a given angle. Now the next bit is that is scaling. See that when you are going to see that any object, if it is not visible without any we take it as a smaller or bigger, we can make that more magnified or less magnified, or increase the size and reducing the size of the objects. Okay, it is, we call that the scaling. In especially in CAD, computer aided engineering drawing, we are using this part is a in a maximum time we are going to use this. In the scaling, we have to increase the size of the object, we are going to reduce the size of the object. Here the scaling transformation changes the size of the object. That means it's a resizing of a given two-dimensional object. This operation can be carried out for polygons by multiplying the coordinate values x and y of each vertex. Be scaling is a scaling factor sx and sy to produce the transformed coordinate axis x dash and y dash. Now directly we are going to consider that as a sx and xy is are the scaling factor in a x direction and scaling factor in a y direction, or take it as a x coordinate or y coordinate. Now when you are going to find out, there is a one object which is placed in a x and y environment, a b c and d. This is the one size, take it as a 1:1. now this is the size of the object. Now in a second object, in a second figure, we have to increase the size of the object. What value we are going to get it? Now you just see that a dash, b dash, c dash and d dash, when I'm increasing is 1:2. Now what happened? Say that x value changes, y value changes. Then the direct formula we are going to use, x dash is equal to x into sx, y dash is equal to y into sy. And similarly we have to find out the x dash and y dash for a given or a scaled factor or a scaled transformation. X dash and y dash is equal to x y matrix into sx 0 and 0 sy. This is the scaling matrix or scalar matrix what we are going to use. And now we have to multiply with this, then we are going to get that x into sx, y into sy. Now this is a p into s, that is we call it as a p dash. P dash is nothing but it is p into ps. And here also I am taking one example. Scale the polygon with the coordinate a is equal to 2, 5, b point is 7, 10 and c is 10, 2 by 2 units in x direction and 2 units in y direction. See that sx and sy, they directly given as a 2 unit. And one thing you remember that here there's 3 conditions are there. When the value of sx and sy are greater than 1, then the initial size of the object increases and it becomes bigger. When sx and sy values are less than 1, then the size of the object is reduces. If it is the size of the object is something whatever the value they given, when these values are less than 1, then the size of the object is reduced. That's the scaling point is minimum. Okay, when greater than and when less than. If the sx and sy values are 1, then what happens? Is there any idea? That means if it is a greater than 1, then size increases, less than 1 it is size decreases. When it is sx and sy are 1, then it is a uniform scale. That means there is no change in the scale of a two-dimensional object. And these are the 3 points you should remember. Now come to this point. Here the given A point is at 2 and 5, the B point is 7, 10, and C is at 10, 2, and this is the position of the scale, the position of the polygon. Now we have to scale it up to the Sx and Sy is 2, then it is a greater than 1, that means the scale of the object increases, that means the object is away from the origin of the point. Remember this, when it is less than 1 it is come nearer or to the origin, when it is greater than 1 then it is away from the origin. Now the object matrix they given, the initial object matrix they given is 2 5, B is 7 10, and C is 10 2. Now A dash, B dash, and C dash, it considers this. Now 2 5, 7 10, and 10 2, these are the, this is the XY matrix. Okay, as earlier said that there is a P matrix, and the Sx and Sy are the scaling matrix. This is the scaling matrix, and this one is the P matrix, is the initial matrix. Now we have to multiply. There's a 3 row 2 column and 2 row 2 column matrix. We have to multiply it. That means we are going to get 2 into 2 4, that's 2 into 2 4, plus 5 into 2, that is 0. 5 into 0 0. Now it becomes 4. Then second, 7 into 2 14, plus 10 into 0, that is 14. 10 into 2 plus 2 into 0, 20 plus 0, that becomes 20. Now for the second, 2 into 0 0, then 5 into 2 10, that means 0 plus 10 is equal to 10, here the 10, then 7 into 0, then 10 into 2, then 10 into 0, 2 into 2, that is 4. When I am going to solve this matrix, multiplication of these 2 column 3 row and 2 column 2 row matrix, then we are going to get, this is the answer, that means 410, A point A is 410, B is 1420, and C is 24. Now the point is A is 4, X is 4, then Y is 10, then for this 14 is X, 20 is Y, then the third position is X is 20 and Y is 4, because see that here the 2 and 2 multiply with these, 2 into 2 4, 5 into 2 10, see, then 2 into 7 14, we are getting 2 into 10 20, then 2 into 30, and 2 into 2 4. When I am going to give 5, then what happen, we are going to get 10, then this one 5 into 10 50, then 14 into 5 20 into 5 20 into 5 4 into 5, and this is the matrix which is scaling matrix. How we are going to increase the scale, and especially you just remember those three conditions: Sx and Sy is greater than 1, less than 1, and equal to 1. Now I am going to show that a simple examples like that. See here, now I am considering this one. Now the translation is here, it is a 1 point in a xy coordinates, where I am going to move it to another position, and the second one is rotation. Now this is the x and y position, A, B, C and D. Now I am going to rotate it at an angle, whatever the angle I am going to take it. This is the initial angle phi, then I am going to rotate it what is the angle I'm going to get it, that is and the scaling factor we have to increase or reduce the scale of the object. And this is all about a 2D transformation of a two-dimensional object we are going to use in a computer graphics. And these are the three basic conditions we have to remember. One is the translation or transformation of the two-dimensional object, rotation of the object, and scaling of the object. Thank you very much.